Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about kinetic molecular theory. Kinetic molecular theory, and this theory represents physical properties of gases in terms of the motion of individual molecules. You can see here average kinetic energy directly proportional to Kelvin temperature. Gas molecules are points separated by a great distance. Particle volume is negligible compared to gas volume. Gas molecules are in rapid random motions. Gas collisions are perfectly elastic. Gas molecules experience no attractions or repulsions. So my friends, you can see kinetic molecular theory. So average kinetic energy K is given by K is equal to half mu square, U square is equal to summation of U square and N. Kinetic molecular theory, you can see the presentations of graph. It is Maxwell speed distributions curve. Now ideal gas law. The ideal gas law illustrates the relationship between pressure, volume, temperature and moles. The formula for the ideal gas is PV is equal to inert. In this formula, P is equal to pressure, V is equal to volume, N is equal to moles, T is equal to temperature, and R is the gas constant. Now friends, universal gas constant, you know it very well. Now Boyle's law, you know P inversely proportional to V, P1 V1, P2 V2. Charge law, you know V directly proportional to T. So this equation can be used to solve for initial and final value. Volume of temperature under the given condition that pressure and the number of moles of the gas stay the same. Now you see the Avogadro's law, you see Amontons law, standard temperature and pressure STP. What is meaning of STP? Two things you should know about this is listed below. The universal value of STP is 1 atm at 0 degrees Celsius. Note that this form especially states 0 degrees Celsius, not 270 Kelvin, even though you will have to convert into Kelvin when plugging this value into the ideal gas equations. Any of the simple gas equation. In STP, 1 mole of gas will take up volume of the container. Now friend, Dalton's law partial pressure. In a mixture of gases, the partial pressure P total is the sum of the partial pressure of the gas. So P total is equal to RT by V summation of over N. Dalton's law allows us to work with mixture of gases. Now friends, Dalton's law partial pressure for a two-component system, the moles of component A and B can be represented by the mole fraction Xa and Xp. You can see. So Dalton's law of partial pressure, mole fraction is related to total pressure. So on a humid day in summer, a mole fraction of gases to water vapor in the air at 25 degrees Celsius can be high as 0.02 Celsius. Assuming a total pressure of atm, what is the partial pressure in atm of water in the air? Now behavior of real gases. Deviations results from assumptions about the ideal gases. Molecules in gaseous state do not exert any force, either attractive or repulsive, on another. Volume of the molecule is negligible, small compared with that of the container. So friends, behavior of real gases. At high pressure, particles are much closer together and attractive forces become more important than a lower pressure. Now, the volume taken up by gas particle is actually less important at lower pressure than at higher pressure. As a result, the volume at high pressure will be greater than the ideal value. So, you can see the behavior of real gases, test of ideal gas behavior. So there is no ideal gas. All ammonia is real gas, H2 is real gas, CH4 is real. So PV by RT versus P plot for 1 mole of gas. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.